Okay. Tonight we are going to look at for loops. And before we get into that, I wanted to mention that this is week 9. And next week we have the second exam. And I have posted a little handout on D12. And let me share it with you. Okay. Yeah, so this is going to cover stuff that we did after the first exam, essentially. But of course, as you know, how can you ask a question in Python that doesn't cover assignments, arithmetic, and all that? That is impossible. I mean, almost impossible. So you will have to know the stuff that we covered before the first exam, but the emphasis will be, the questions will be directed to topics that we covered after the first exam. So that includes things like if statements, if, else part of the if statement, then Boolean expressions. We covered while loops last week, and we are covering for loops this week. So all those things will be on the exam. One thing you have to pay attention to is this. Please read this carefully. Some of you, I know, have experience with Python. You know some of the advanced concepts that we haven't discussed in class. In the exam, I am testing for specific concepts. I'm looking for whether you can use if statements in a certain way, write conditional expressions in a certain way, etc., etc. So do not use any concepts that we have not discussed in class. You cannot use functions. You cannot create functions on your own. That's what I mean. If you know what a function is. You cannot use sets or dictionaries or lists or any of those things. If you use any concept that is not discussed in class, you are likely to lose credit. Because I'm looking to test specific concepts. For example, I might test to see whether you're able to use elif in a certain way. And if you use some other strategies and not use elif, you will lose credit, okay? So please pay attention to this, because I don't want you to be disappointed at a later point, okay? So when you use a concept, ask yourself, was this covered in class? If not, don't use it, okay? That is the main thing. There will be 5 questions, 15 points each, that ask you to write code or ask you to play with expressions, that kind of stuff. And then there will be a few questions on the 2 readings that you had, that is like 4 questions each on the 2 readings after the first exam. And then there will be a few questions on Python. That is the structure of the exam. Any questions? So let me emphasize again, do not use any concepts that are not discussed in class, and read the questions carefully, because they test for specific concepts. Follow directions. Otherwise, you may be losing lots and lots of credit. Don't do that. Okay. I may not get a chance to repeat this next week, but I expect that you will go through this document and pay attention to this. And you must submit the answers to the first 5 questions in a Python file. Before turning it in, make sure that the code can be executed. Do not comment out your programs. If you comment out your programs, I will not uncomment them. If there is a syntax error in the file, it is likely that none of the code will get executed and you might get almost no score. So make sure that your code can be executed. If not, it is going to be difficult. Okay, so it may be a difficult situation. So before you submit that file, run it and make sure that all the code can be executed. That takes only a minute or two, just run it once and then quickly give some input and then see that all the code gets executed. Don't even worry whether the answers are correct, because you must ensure that the code can be executed, otherwise you won't get credit. Okay, so I ask you to pay attention to these aspects. Okay, any questions? All right, I want to talk a little bit about for loops. It is covered in the video, but I will spend a little bit of time showing you a couple of programs that use for loops. I'm not going to discuss the concepts from scratch. I will show it in the context of problem solving. These programs are there around D12, and there is some explanation of it, but I will go through these again. So let's see these 2 programs. Okay, let's run this program and see what it does, and then we will go through the code. So let me execute it. Actually, you cannot see it probably. So I'm going to stop this share and share my desktop. Otherwise, you won't be able to see the execution. Okay, this is a turtle program. So it asks for the x coordinate of a point. Actually, it is going to draw a bunch of colored rectangles. So let me just give some like -100. So it is 100 pixels to the left of the center. And let's make it -200. So it is 200 pixels above the center. So it is a little to the top left of the center. Now it is asking for the side of a square. That is, how many pixels are there on the side of every square? Let me just give something like 20. And it is asking for the number of squares. Let me say 7. So this will draw 7 rectangles that are colored. You will see the behavior in a second. So each side is 20. So height of 20, width of 20. Let me hit enter. So you can see that it has drawn 7 squares. So it is 100 units to the left and 200 units down. So it is red, green, blue, red, green, blue, red. So it drew 7 squares, and we have to just believe that these are 20 pixels wide and high. I mean, we can't really measure that, right? So that is what the program does. So you have to have a loop to draw these squares. So what happens is there is code to draw 1 square, and that is going to be repeated these many times. So if you say number of squares is 7, we draw one square and repeat it 7 times. So the number of times we draw a square is kind of known, is fixed. The moment you accept the input, you know that you have to draw 7 squares. So you don't have to look for some arbitrary condition. You know the number of operations. If that is the case, it is most appropriate to use the for loop. So we have a for loop here. And here within the loop, we have code to draw one square. So all this code here, starting at if color equals 0, all the way to color equals color plus 1% 3, all this stuff is to draw one square. And it is repeated 7 times. Before getting into the for loop, we accept the input, getting the top left corners x and y coordinates, the side of the square, the number of squares, and we set a variable called color to 0. And we hide the turtle. That is not all that important. Okay. So we got the position of the first square, then side of each and every square, and the number of squares. And notice this color equals 0. And we have the for loop here. So we write for. Last week we did while loops where we wrote while in lowercase. Here we write for in lowercase. When you write a for loop in Python, what you need is a variable. Immediately after the for, you must put a variable, invent a variable name. That seems appropriate. Like we are drawing squares, so I'm calling it square, right? Instead of calling it number or index or something, I'm indicating that I'm drawing a square by giving a variable name called square. So the syntax is to write for, then put a variable name, and you always put in. So it is very simple to remember: for a variable and then in. And then things can get a little more complicated than that. So you say essentially how many times you want to repeat the loop. So the number of times you go through the loop is fixed by this expression. One of the things you can say is range and give a number. We know that number of squares is already known. For example, we had 7 in that execution. So we write range 7. If you write range 7, the loop will execute 7 times. Okay. So if you write 4 square in range and then put 7 or 10 or whatever, the loop will execute that many times. How does it actually work? It is a little more complicated. When you write range and give a number, in this case, we are putting a variable, but that contains a number. So when you give range and a number, it generates a sequence starting at 0 and repeating, or rather, the sequence is 0, 1, 2, 3, etc. And if number of squares is 7, it ends at 6. It doesn't get to 7 or cross it. It just stops before hitting 7. So the sequence, this produces a sequence, range, number of squares, 0, 1, 2, 3, 4, 5, 6. And square will be set to 0, and this loop will be executed. Then square will be set to the next element in this sequence, which is 1. This loop will be executed. Then square will be set to 2. The loop is executed. And it goes on and on and on until square becomes 6, the last element of the sequence, and this loop gets executed or iterated. And then the loop ends because the sequence has 7 elements: 0, 1, 2, 3, 4, 5, 6. Is that clear? And like a while loop, you need a colon after the end of the loop header. This is the loop header. This is the target variable. I'm not really using the target variable here, but sometimes you use that. Sometimes you don't use. But you need the target variable. Now I'm first deciding on the color. If color is equal to 0, I'm saying turtle's color is red. Otherwise, if color is 1, I will color it green. Otherwise, I will color blue. That is the first action within the iteration of the loop. Then I lift the pen up and go to the top left corner. I got the top left corner here, X and Y coordinates. I'm going to go there and I will put the pen down, and then I will simply draw one square. I'm not going to spend much time explaining this. You know how to draw a square by now, right? So all this code does is draw one square and color it with whatever color is assigned by this. Then what I do is I ensure that the next square will be shifted to the right. So X top left is X top left plus side. So here is my first square, where my mouse pointing to is the top left corner, X top left, Y top left. After I draw the red square, I'm going to advance X top left by side. So X top left is now here. I don't need to change Y top left. That is always going to be the same for all these squares. So after drawing the red square, I change X top left to X top left plus 1. I'm trying to move this. Okay. X top left by side. I'm sorry. And then I add 1 to color and see what is happening here. Color is 0 initially, so I will be choosing red. After the drawing of the red rectangle, I'm adding 1 to color. So color is now 1. And then I take the remainder after division by 3. So color would be 1% 3, which is again 1. So I will draw the next square here because I had put number of squares as 7. So here, when I am iterating for the second time, color is 1. So turtle's color would be green because of this if-else structure. Then I will come down and go to X top left and Y top left. X top left has already been changed. So I'll be drawing the green square here, and I will advance again the X coordinate to move to a different position. So from here, I'll be moving to here. And then I add 1 to color. So color would be 1 plus 1, 2% 3. 2% 3 would be 2. So I will set color to 2. X top left would be at this point, and then I will go back and draw my next square. Color is not 0, it is not 1, so it will hit this line, turtle.color blue. So the turtle's color would be blue, and I am moving to X top left, Y top left. X top left has been changing, right? So X top left is now here. Y top left is still the same. Then I will be drawing one square and coloring it, so I get the blue square. Now something interesting happens. Of course, X top left is going to be advanced to go to position here and see what is happening here. This is a useful trick that you see used in computer science all the time. Memorize this. We are going to add 1 to color. Color is 2. Add 1, you get 3. 2 plus 1 is 3. %3 would give you 0, because 3 would be evenly divisible by 3 with a remainder of 0. So color would now cycle back to 0. This is a useful trick. You see it in many, many algorithms, many techniques. It is useful to have these tricks in your bag so that you can just use them when you need. Okay. So if color is now 0, turtle's color would now be red. And then you draw the red, then green, then blue, and then the last red rectangle would be drawn, and you would have exhausted this sequence and you will get out. And that will be the end of the loop. Let me pause here for taking any questions. Any questions on this? Okay, if you don't have questions, let me go to the next example. What this does is it draws a bunch of squares, okay, a grid. Let me run this. Once again, it asks for the top left corner. Let me put -100, and Y coordinate, let me put 200. Width of a rectangle, let me put 30. Height, let me put 20. And let me put 8 here and explain what is going to happen. I will get a grid of 8 rectangles horizontally and vertically. That is what this program will do. The width of each rectangle would be 30 pixels, height would be 20 pixels. You can see how it is going to draw this now. You see, it is drawing horizontal lines to get 8. And now it is drawing vertical lines, and that's it. So it drew enough horizontal lines to get 8 rectangles, 1, 2, 3, 4, 5, 6, 7, 8, and enough vertical lines to get 8 in this direction as well. Instead of drawing rectangle by rectangle, it just draws a number of horizontal lines and a number of vertical lines. That is the plan. So we are going to have 2 loops, one to draw the horizontal lines and one to draw the vertical lines. And here is the code. We have code to get the top left corner, and top left corners X and Y coordinates, and the width of the rectangle. And if the width is more than or equal to 5 only, I do anything. If the width is very small, I don't want to draw it. That is my plan. I mean, if the width is very small, it's going to look pretty awful. I didn't want to do anything. So if width is more than or equal to 5, I get the height. And if the height is also at least 5, then I draw. Otherwise, I will do nothing, right? If the width is less than 5 or the height is less than 5, this program will not draw any rectangles. If the width is at least 5 and height is at least 5, I ask for the number of rectangles. And if the number of rectangles is not at least 2, I will quit. If it is 1 or negative or something or 0 or whatever, I don't want to draw anything. So there has to be at least 2 rectangles to draw, and the width and height both have to be at least 5. 5 is the total. And I have 2 variables, x and y. X equals x top left and y equals y top left. So this is the top left corner. Where is that? This is the top left corner, x top left, y top left. So x and y are pointing here at this point. Now I need to draw, if I want to draw 8 rectangles, I have to draw 9 horizontal lines and 9 vertical lines. If I have to draw 20 rectangles, I need 21 lines. So for rectangle in range, number of rectangles plus 1. So this will draw a number of lines. Let's see how it is going to draw, right? Whether is it going to be vertical or horizontal lines? We will see. We lift the pen up, go to x comma y. So we are going to go here because x is at the top left corner, y is at the top left corner. So I am going to the top left corner. I put the pen down and I am going east, and I move forward by how much? Width times number of rectangles. If width is 30 and number of rectangles is 8, I will be moving horizontally. That means I am drawing a horizontal line for 240 pixels. So I'm drawing this entire line. 8 is the number of rectangles, 30 is the width, so it is 240. So I drew one horizontal line, and then I will move down. So y equals y minus height. After drawing one line, I go to the place to draw the second line. I'm not changing the value of x. X is still going to be the same for all these lines. For all the horizontal lines, they all begin at the same x coordinate. It is the y coordinate that gets changed. So I subtract height from y and go back and draw the next line. And then the next line, and so on and so forth. I will draw as many lines as this value, number of rectangles plus 1. Questions about that loop or anything that has happened within this program? If you understand that, then the second loop is very easy. I am doing the same thing here, x equals x top left, y equals y top left. And then I again have a similar loop, number of rectangles plus 1. I am going to go to x comma y, put the pen down, and I am going down. Set heading 270 means go down. So I go here and set my direction to go down and travel this much distance. So it is essentially this very similar code, turtle.forward height times number of rectangles. Instead of width, we are using the height to decide how long these vertical lines should be. And after drawing one vertical line, I need to shift my position to the right and then draw the next vertical line. So I shift by width, x equals x plus width, and I draw the next vertical line, and it keeps going. All right. Any questions before we close this? As you have seen in the book and in the PowerPoint, there are various different ways of writing the range function. You will have questions on those kinds of things in the class exercise. Any questions before we go to the class exercise? All right. If you don't have questions, let me stop recording and